Okay, so in order to calculate the pH for a weak base solution, it really only involves one additional step. And so let's go ahead and just sort of get into the calculation. To start with, if you have a base, then you need a base ionization reaction. So that's the first thing that you have to do is write that. And I've already done that for this one. It would just be the base plus water makes Hb plus OH minus. And this is just a generic reaction. And so I have to set up an ice table, right? Once I have that, and I know my initial, sometimes it doesn't want to write and I have to poke it over and over again. Initial, change, and equilibrium, and we'll just draw lines like this. And then, again, I cross this water out so I don't get confused by it. And then my base is 0.15 molar. And then my conjugate acid and my hydroxide are both going to be 0 initially. That's the assumption. And this will be minus x. These will be x, and this will be 0.15 minus x, and x. And Kb expression, just like a Ka, right, is products over reactants. So it's going to be Hb plus conjugate acid over and OH minus over the concentration of the base, like that. And so now I can plug this in, and I hope you're recognizing that when you do many of these problems, you're going to get this same form for the answer. It's the x squared over the concentration minus x, and that's 1.5 times 10 to the minus third. Okay, so now I'm going to plug that into a solver, and I'll show you the result of that calculation. And that's the result of the calculation. It's 0.143 roughly. So 0.143, and we'll put that back onto the other side. And I carried a couple extra sig figs. There's really only 2, but it didn't hurt to have a few extra. And then we want to calculate the negative log of x. But remember when you're doing these base ones, because you sort of get in a groove, this is the hydroxide ion concentration. So you're not calculating pH at this point. You're just calculating pOH. So pOH was what you'll get out of base calculations. That's negative log of x. So again, I'm just going to go to the calculator, negative log, and then I'm lazy. I don't want to write the number down. I'll hit enter, and it's 1.846. So 1.846. And then pH is just 14 minus that value. And that's 12.154. Now I have 2 sig figs, so then I'll worry about it down here. So that's 12.15. And kind of a nice way to check on these things, if pH is high, it's basic. So if you put a base in water, your pH should be greater than 7. And if you put an acid in water, it's less than 7. And typically you don't have problems with acids, but when you do the calculations with bases, there is this tendency just to do like negative log, and then you're all thrown off when you get your weird answer, okay? All right, but at least you'll know it's wrong if you skip that pOH calculation step. You'll get a pH that just makes no sense at all, right? Good. All right, so here's your opportunity to do a problem. This is pyridine. It's an organic base. You don't need to know the formula for these things, really. So go ahead and try to calculate the pH of a 0.035 molar pyridine solution. The Kb value, I looked it up, is 1.7 times 10 to the minus 9. You'll pause it, and then I'll come back with it worked out and walk you through it. Okay, so that's the solution. Now, I started with my base ionization reaction. I put in my initial concentration and assumed these are 0. Again, it's minus x and then x and x, so it's 0.035 minus x at equilibrium and then x and x at equilibrium. The Kb expression is generally always the same because the reaction is generic. And then you just plug in the value. So you get x squared over 0.035 minus x. That's equal to 1.7 times 10 to the minus 9. And now what we do is we run it over to the calculator, and we can solve the equation, which I already did. So it's 7.71 times 10 to the minus 6. So x is 7.71 times 10 to the minus 6. And then we can calculate the pH. So we'll go negative log of x. Hit enter, and it's 5.11. So pOH is equal to negative log of the x value, because that's representing the OH. So that's 5.11. And if I wanted the pH, then I just have to do 14 minus that value and hit enter. And that becomes 8.89. Nine, 8.9, yeah, 8.9. Again, that's calculating the pH for a solution of a weak base. Very similar to a weak acid. It's just this one additional step where you're calculating pOH instead of pH.